name's Manish Kalra. I'm visiting here from San Francisco, and thank God it's warm. I was told to watch out for the weather. I packed inappropriately, a lot of warm gear, which I'm not going to need. But thank you for taking your time this afternoon to come join me. Hopefully it'll be an eventful session for you that you'll take something away, and happy to talk offline about anything. My email address is really simple, manish@swim.inc, Twitter @mkalra. So we're going to talk about stream processing with Apache Kafka, but really we're going to talk about stream processing because through the sessions this week, and of course talking to different individuals, it's not just a Kafka-based world. There's other streaming technologies people are using. So everything we're going to talk about really does apply to those principles. So if I say stream, insert your choice that you're using. We're going to talk about stream processing, streaming applications, this new concept, a bunch of demos, and then an intro to how we can build some of this stuff with no cost upfront with our OpenOS. So we were just talking, some of the worst times to have a session is before lunch, after lunch, and before happy hour, right? You're blocking lunch, you're asleep from lunch, or you're blocking drinks. So you guys need to wake up. Right? So we are going to play a game. And it's a game related to what we're going to be talking about. So everyone in this room is going to become a data stream. We're going to process that stream real time. The upside down faces, because I hate using the word real time, but I couldn't think of anything else. Because if there's ever a word that's been destroyed in the English dictionary in the world of data analytics, data space is real time, near time, sort of there, milliseconds. So let's just call it real time. Everyone in this room, if you decide to partake, will be a producer of the data stream, but also consumer. Because that's really important for you to understand that a data stream can be produced, and we're used to that, right? We look at the data on a dashboard. But how about if you have to inherit it? So everyone's also going to be a consumer of that stream. And then we're going to watch for the results. So if you'd like, if you have your phone, go to, on your Chrome browser or Safari browser. DuckDuckGo does not work with the demo. I tried. Go to ripple.swim.ai. And when you start, I'm going to show the demo up here. What's really happening is each of you, as you tap that screen, I need you to tap the screen, a stream is being created. Sorry, tap the screen, a stream is being created, and that data is being sent from Boston to Portland. And I'll show you what's going on. So this is just a really simple application. This is all of you generating that data in a data stream right now. So this data, you'll be able to see your color as you hold your finger down. Now, if you really want to see what's going on and how a stream can be generated and correlated together and how we come together, hold your finger down. And now what's happening is all of you are generating a data stream in this room. It's being sent to Portland, the AWS data center. It's being processed. The stream is being processed. Now, all these streams are coming in individually. So now they're being aggregated together by a broker. Then they're being sent to a Swim application. That Swim application is processing, and I'm going to say the word, real time, and then displaying it and sending it back to you. Now I'm putting it up here on my laptop, but it's also coming back to your phone. That's the latency we're dealing with stream processing, right? So this is something you can try. It's available anytime, not for this application. For this session, but yeah, this is everybody becoming a stream. Now, the reason I wanted to throw and start up with this is not only because everyone's tired. It's really about this principle, right? The challenge of organizations and how to know what is happening right now, right? We talk about that all the time when it comes to processing data right now. And thus, I'm out of words in the English dictionary, right? I pull up the thesaurus at times going, what do I use here, right? But all of you, let's just forget all that stuff. It's about what's happening right now with your business, your situation, whatever, right? And what matters most, and really solving problems. Now, what's a problem? I can't define that, right? A bus is late. If you work in a agency, municipal agency, that's a problem. Your rocket ship didn't take off. I can't find it. That's a problem. Right? You define your problems, and in your environment, they become crises if they happen once, twice, 3 times, or over and over again. So the challenge is that today, when we think about solving those problems or ingesting data, the typical approach has been to store and analyze, right? Let's take all our data, let's put it somewhere, and let's analyze it, right? Nothing wrong with that concept, 100% true. It's going to be true for a long time. And really, it's dependent on your industry, right? You have to keep data for a certain time in certain industries, 7 years, whatever regulatory. But really, there's a lot of data you don't got to keep, and I'll talk about that for a second. But we call it legacy store and analyze because streaming is not legacy. This is something that's new, that's really taken off, right, in the last couple of years. I mean, Kafka a few years ago, what the heck was that, right? This concept of IoT devices, all these things generating data. These same things were there, but then all of a sudden someone decided, let's put something on them, a computer chip, something that communicates, generates data, and then we should know what's going on. So all this data is coming in at incredible velocities, right? And there was a very short period, we called it big data, volume, velocity, variability. Remember all that stuff that we used to talk about? And now there's no such thing as big data. It's data, man. It's just data. There's so much of it. And really, when it comes in, how do you get that streaming intelligence out of it? The biggest challenge, the number one challenge about streaming data, it never stops. You are processing data as it's coming in. How do you ever catch up, right? So we had one client, I'm going to get into it, I'm just jumping ahead. They decided to keep everything. So what happened is 400 node HDFS cluster because they did not know how to get through it. And that is a common business model. It is better to be safe to keep everything than to realize, dang, we should have kept that. Right? We did not know. But how do you decide what you need now versus what you need as per regulatory, financial, blah, blah, blah regulations? And really it gets down to, do you need to store everything, right? To understand your current business situation. A thing that's really important about your streaming data is it something you need to keep forever? Or is it something you need to understand your current situation, and that situation has happened, it has passed, and you no longer need that data? My current situation is I'm standing on stage here in Boston. My cell phone provider may need that data right now for my service level. When I fly out tomorrow morning, why should they archive my data that Manish was standing in Boston for the next 7 years? There's absolutely no need for that. And there are situations over and over again in your organizations or people you work with that data is being kept that you don't need. So that's part of the things. What is your current situations that you need to think of? And that gets down to the consultant answer I'm about to put on here, right? For certain use cases, that data is not needed. So in certain use cases, when you have a stream coming in, traditionally today, you disrupt the stream, you send it to storage, you apply business logic, and then you view data. And I call that old data. Old data is defined by you. What I mean by business logic is there's data coming in. What are you going to do with it? What are you looking for? That is your business logic, right? Is it a query of a username, location, whatever you need to know about them, cell phone provider, how much minutes they use? That is what the business logic and we'll get into that for a second, in a second. But you need to apply that logic. Now, if that logic is being applied from a streaming application, a streaming pipeline, fire hose, whether it's Kafka, Pulsar, et cetera, and then you're sending it to storage, it's still coming in and you're processing something, is it old? You need to define. You need to tell me it's old. Like I said, for certain people in certain situations, 30 seconds of data is old. So let me give you a quick example of where you need to think about what old data is and why processing is important on your business circumstances. This is satellite orbital data that we're taking in right here. Imagine if this data was 30 seconds old if you were looking at it, right? Two satellites coming at each other. We're sending this satellite stream after all these satellites to a storage unit, and then we're running a query on it. Now, if we were to take a look at all the satellites and start blowing things up. This thing gets really populated. It was kind of scary when I first looked at this data of how much space junk is out there, like stuff we just leave. Like, you know, we see the part of SpaceX and the Falcon Heavy taking off, and it's one rocket, but we've been doing that for a really long time, and a lot of countries have been doing that. So there's a lot of space junk out there with these rockets going out there. And when they're going out there, they're sending streams of data. There's all kinds of telemetry data coming in. This data can't be 30 seconds old. This data can't be 10 seconds old. They need to know if something's coming at them right now. That's why your business problem, your current situation really matters when processing a stream. And I'm going to get into more specifics about this on how we built this specific application. This is available to be built publicly just to see how to actually do it. But then I'm going to get into real-time data applications in a second. Any questions on this trajectory stuff? So orbital simulation. So it's, what we're trying to get at is you got to understand the current situation, but you have to do it without disrupting the stream. As soon as you do that, you lose the current situation. Now, I'm going to put the asterisks on there because you define the current situation. I've spoken to people today, 5 minutes of old data works for them. 10 minutes work for them. There was a vendor I'm talking to, they help people understand. He said, you know, we're really looking after data that's 30 days old. That's great because you have to do a bunch of stuff to data that's 30 days old. Once you've reconciled it, that's your business situation. But if you live in a situation where the data's coming in and you need to understand it right now, it's about the fact that you cannot disrupt that stream. And it's not really about what the current situation is. Does it really matter what's coming in? There's a lot of flags that come up in streams, Kafka streams, Pulsar streams, whatever, that does this data really matter? And the answer is no. A lot of the data coming in does not matter. Then there's why did it happen? There's your oh crap moment. And what happens? What is the impact of some of this stuff if it does keep going on? Now these questions are really from your business logic. I need to know when things happen, why they happen, what data sources, and what happens if A plus B happen at the same time. That's an outlier case. It'll probably happen, and D will take down my partner network or whoever you deal with, whether it's partners, customers, etc. So the first step on when you're looking at processing a stream is apply business logic to the in-flight stream, right? What is it that you're trying to get out of this? The failure that we see or when we start engagement with customers is, what are you trying to find out? Well, everything. No, you're not. You're not trying to find out everything. You get your business units together and you say, what are the questions you would ask your stream? Literally, it's like saying, what would you query after the event? Well, you would want to know all these things after the event. So let's ask those questions right now and apply the logic today to the in-flight data, not waiting for the event to happen. A lot of times we get into data analysis, data queries on finding out what happened, right? The post-mortem. I'll go find out why X went down, shipment was missed, trucks went the wrong way. That's okay too. But if you want to reroute your trucking system because it got the wrong orders, you can't wait after the effect. Because organizations today are competing with Amazon and they have time guarantees and they have to reroute their trucks in the right direction for the shipping life cycle, right? We already know what's happening with the supply chain right now. 2 hours means lost orders, when if you're an organization like Walmart that says your thing is going to be there at the counter at 6 p.m. and it's not there till 8 p.m., well, guess what? You promise some penalties now. So there's certain things that have to happen in flight that cannot wait for the next day aggregation. So how do we do that? So we came up with this concept of thinking about business logic as streaming applications, right? So streaming applications are taking the analysis you need, right? The business logic, the questions, the queries you need, and apply them to to streaming data. From wherever you need it from. The examples are infrastructure, services, devices, shipping lanes, etc. It's what you need to know. The sources, what sources does it come from? It's not one thing, right? What sources are needed to be combined for you to understand this? And when does it get generated? Is it every second, hourly? And I'll show you some demos about data being generated right off the bat. Integrate that streaming and static data if you want to, because there's some certain situations, there's some stuff coming in, but it has to be related to what maybe you already have. Location data might be something in a warehouse, A plus B is what you need. Apply that logic over and over again. The biggest thing about when you're processing a stream is that the data analysis does not stop. It's not a query that gets run, you wait for the output. It continuously gets applied. Why? The stream's not stopping. So if you applied it at this point, it's gone. So you have to over and over and over again. So the concept you have to think about is that you don't bring data to a query, right? You don't bring it to a store and then run a query. What you need to get your head around is you need to apply logic, bring logic to the data. And that's the key difference now. You already know the logic. You guys are subject matter experts in your industries. You already know what's needed. So why wait until the thing happens and then you're like, let me look at the dashboard now? No, apply the logic now, and every second keep applying it, keep applying it, keep applying it. Then modeling starts happening because the streams keep moving. They're changing. But your data also keeps up to date, and we'll get into that in a second. Why this, right? Why now? This gentleman and I were talking earlier about this, right? About how streaming, Kafka, Pulsar is still relatively new. You might be the data subject experts in your organization on that. Now go outside the organization, into IT, into the data units. They're not looking at that. They were brought up on ETL. They were brought up on databases. So let's look at that concept. Let's look at it from that lens. Databases had database application, right? That's nothing wrong with that, and we still have them today. Then we got into big data applications, HDFS applications. Once again, completely okay. Sets of data need the requirement of the application it's designed for, and now we're talking about streaming data. So let's use that same concept. How do we apply the logic to that? And we call that streaming applications, right? Streaming data needs streaming applications. So, what do we do here? Very first thing, one, create the business logic about what you need to know about your service, infrastructure, customer, and partners. Think about the outage, think about the impact, think about your penalties, build those questions. I need to know why servers go down, telecom X tower is up, service levels. Build the questions you need to know now. Take that logic and then apply it to the stream. Don't let the stream come to you. Apply it to the data that's being generated every millisecond. Then apply those insights directly now. Now take that application you've developed and apply it to the data stream. And then from that, what you're getting now is what we call streaming answers, because that visualization, like that Ripple UI, is changing every second. That's the word I hate, real time. It's continuously updating. So let's think about it that way. Your data stream is continuously coming in. It's not stopping. Your business logic is continuously applying, and your answers are continuously updating. Your answers are reflective of the data coming in. Very simple. If your data coming in is changing at a certain clip, your answers, right, your queries, your logic should also be changing at that exact same clip. So let's look at a couple of examples of how you're taking Kafka event streams, processing them in real time, and building with these streaming applications. So I've got a couple of examples here. A couple are live. Like this was actually built out of downloadable data. But I want to show you this example. This is a Kafka stream coming in for the city of Palo Alto, outside of in Silicon Valley, where Stanford University is and a bunch of startups have happened. There's this company called Cubic, right? They do this stuff called smart cities. So they go to cities and say, hey, you got the smart city initiative. We'll look at your traffic patterns and help you. So Palo Alto is a customer. So this is data we're seeing. So what you see here, now this is not all the data, this is what we're allowed to showcase because there's a lot more data going into here. So an example of what the city of Palo Alto wants to know is what's happening with their traffic light system. Red light, green lights. And so this is happening continuously, I didn't say real time, continuously of the number of green lights, the number of red lights. And what you see here, these purple dots, this is Jane Doe or John Doe standing at the intersection hitting the button to change the light. If you guys ever wonder, anyone sees that button? Well, the city of Palo Alto is, well, they're looking at it. I'm not sure if it does anything. The real reason is, you take this strip right here. I believe this is, this strip in Palo Alto is horrible. It's a traffic jam. It's where the restaurants and bars are. You go on Friday night. It is a nightmare if you ever think about driving there. And they want to see, hey, lights are green, no traffic is moving. There's been an accident, right? They can't wait for someone to call 911 in case it's not urgent. They got to get a tow truck in there or something. They want to see if big masses of people are actually sitting on corners. This right here as an example, this blue one, no one's standing there. That's just an intersection, a pedestrian crosswalk that hasn't been engaged yet. So they know right now there are 20 people or 20 engagements of that button. There are approximately 92 cars waiting at red lights, and there are 62 cars flowing, right? This data is actually not even coming from Palo Alto. It's a data center in the Midwest. So what the city of Palo Alto has done, working with Cubic, has said, look, all these, we've got these devices, these sensors on these lights, on those switches, what do we call them? Crosswalk signal thingies, and they're generating data. We went ahead with that smart city. We've got all this data. What do? Well, they all put it into a warehouse at one point, and now with Cubic, they're actually processing this data real time. So if you were to stand with a camera and press the button and look at this dashboard, it would be lined up 100%, and we've done that, right? Because they need to know what's happening to their city so they can respond proactively, not reactively when all the calls start coming in. If we take a look at this demo, this is the busing system in the city of San Francisco. They do not move that fast usually, but what it is Muni needs to understand where their buses are. Why have they stopped? Why aren't they moving? Is there an incident on the bus? When you see a ripple, that's actually a transmission of data. So they want to know, you've got this guy right here, this bus driver. Why is he stopped? Is that like, soon you'll discover there's a great coffee shop on that corner. But they need to know what's happening. So once again, the same company, Cubic, is looking at all the buses in San Francisco real time as they're moving, because it's really important for the city of San Francisco. I'm not sure what it's like here in Boston, I apologize, but you've seen those bus stands where it says the bus is coming in 2 minutes and 45 seconds. Well, they got to make sure that bus is there in 2 minutes and 45 seconds. This is part of the data they use because they're using what? Speed. They're using traffic. They're also using occupancy on the bus, because you ever have the bus just drive by because there's too many people in it and the driver can't take any more people on? Well, where's all that stuff coming from? It's coming from something like this, like an organization like Cubic that's taking all that data, processing those Kafka streams, and sending it back in a visualization so the customer can actually see, I'll say it, I won't say it, continuously as to what is happening in the environment. And then what you do is you spread this out, and now we can see what's happening out here in Tahoe. You can see what's happening out in Reno, and it's being spread out because all these cities now need to understand real time about their busing infrastructure so they can keep up with their mandated, promised service agreements with whoever, their city councils, the people, etc. In this last demo of what happens with stream processing, this is Verizon's cell phone tower network. And Verizon, as an example, needs to know what is going on with their tower network in real time. Why? I live out here, Blackhawk. It's gone yellowish or gold. Something's happening there. And now what usually happens is the fact that there could be a problem, and let's just say you're a subscriber with Verizon. You call up and say, hey, I'm having some cell phone problems. What's going on? And that happens. It happens all the time, right? Over congestion, there's a sporting event, and everyone's at one football stadium, and it wasn't spec'd properly. Well, how long do you have, or how long will you wait on the phone for a Verizon customer success agent to sit there and say, hey, Ms. Jane Doe, thank you for calling us. Thank you for being a customer. Let me look into it. Most people will wait, what, 1 minute, 2 minutes? How long before you start looking at a competitor's website if they can't answer your problem, if something is wrong? So sending subscriber data, all this data into a data warehouse and then looking at it after and saying, oh, let me look into it and get back to you in an hour or 2 hours, guess what? They're losing customers now. And now put your business in that situation. Can you afford to lose business? And like I said, your business situation depends on you. 5 minutes is enough time to have a customer on hold. There are certain organizations you have to say, look, I will get back to you in a day. But on the other end, the customer does understand and say, yeah, I understand why. I will get back to you. And then there's situations where people are yelling at the city council because the buses are never on time and the city has a mandate to provide services. A private organization has a mandate to provide services. So the business situation completely depends on you. So let's, whoa, jump too far ahead. So what you need now is a streaming platform, and that's what we've developed. And with a streaming platform, what you do is you can ingest the data at the velocity it's being generated at. But the most important thing, the answers are being generated at the velocity the data is being generated at. That's the only way that you can keep up or provide any value. And then it really depends on what you want to do with that data. So I wrote some examples here of what people are doing. It could be user experience. I want to know what my people, my customers, my partners are experiencing right now because I've promised that. I've promised an SLA. I've guaranteed a particular service assurance. It'll always be up this many times, this many nines. If something happens in my environment where we have those post-mortems, I don't want those. I want to know up in front if this trend keeps continuing. What's the impact? What's the blowout that's going to happen to the network? SLA monitoring, KPI validation, right? Not running in a report after, hey, did we deliver 3 nines? Watching those 9s real time because we promised the business from an IT perspective of what we would do. We designed this particular infrastructure for a particular load. It's being blown away, but we know second by second, not when we run the reports. Fraud detection is a big one, right? Are these things supposed to be happening at this time, right? Let's take an example of buying something, activating something, right? You buy something, it comes with an activation service. Interesting why all this stuff is being activated out in the middle of America, but the purchase order was in Boston. What's going on? Why are the activations happening there? That's fraud, right? I need to know that now so I can shut that down. And last but not least, a simple one, asset tracking. Where are my buses at, right? How fast are they going? We have one customer right now. They deal with supply chain. The one thing that they can do, and they do it really well, is they will take a shipment from a warehouse, put it on a truck. Now, national distributor, they know exactly where those trucks are. You know what the biggest problem they fall into? When the truck actually docks at the store. Because when the items start coming off the truck and into the processing side of the warehouse, some stuff needs to go in the warehouse, the store warehouse, sorry. Some needs to go to the shelf, And certain items need to go to the pickup counter. So where they're falling down right now is the pickup counter. Because they can sit there and say, yep, the truck has arrived at the Boston store. And now the customer gets a ding and says, oh, your stuff is here. Where it is in the store now, no clue. And now you're upset as a customer. You told me it was here. It's here. It's in the warehouse, it's on a lift, or it's on the truck. I can't tell you more than that until somebody finally finds it and brings it to the pickup counter. Now you're upset because you were promised an SLA. It will be here by X o'clock. So how can we do this? So what we did is, a few years ago, founders created this company called SWIM, Software in Motion. The whole purpose of it is just dealing with moving data, right? The software that's always in motion, streaming data. And really the whole purpose is these applications. Build them, but apply the logic to the application, not the other way around. But for certain circumstances, certain situations, the ones that need it, where you need that data. But then you have the option of putting all of that stuff into a data warehouse, HDFS store, whatever you want to do, or even the output of this can go into a data warehouse for you to see later on. The most important thing about this technology, though, is it doesn't warehouse everything, because you don't need to know everything, and you don't need to keep everything. In my case of the example of Cubic and the SF bus system, that bus is gone from that intersection. I don't need to know that it was there 3 days ago. It's there every day. It's there every hour, right? So why keep that data? Why? Well, you could, if you're an Amazon stockholder, maybe. I mean, they're going to love you sending all this data over and over again, but you don't need all the data. So what do? We allow you to connect to the streaming and static data from any data source. Really simple, and I'm going to go through that in a second. Create these closed loop applications, and we say closed loop because they're doing this one thing. You've told them what to do, and they're applying, continuously applying. They're never stopping. Well, when are they going to stop? Well, I guess if your data stream stops down, right? That's a bigger problem if the data stream stops. Analyze in millisecond turns, and of course, give you what you need to know to act now, not when the query is run. So that dashboard right now, all the dashboards I've shown you were all real time. They were happening continuously on the data. So if you were to go into the NOC in one of these organizations, they would have these big screens up with these TVs, I guess, and they would have these maps going. So if one of the buses or a bunch of buses turned red, they know about a collision that's happened on the streets of San Francisco and are sending their version of the tow trucks, or maybe they've called the police or et cetera, to find out. Buses break down. They don't move the actual out of the bus stop area. They know right away as the driver is calling dispatch. The NOC team already knows to send somebody out, and they're already in transit to help people with the bus, a second bus, et cetera, to get them up and going and get that one off the streets, because driving in San Francisco is like driving in Boston. It's hell. And you can't have a bus stopped there. So how do we do it? We're getting there. So basically we create these small in-memory web agents, right? These web agents are the ones that continuously ingest this data. Now, it's a horrible name. I don't know why we stuck with it, because it brings back the days of these big, beefy web agents that agents that went on your computers, would eat up memory, processing power, et cetera. But really, they're really just message brokers. They're tiny little message brokers that you actually install on whatever you want to do, whether it's a Pi device, depending on if you're monitoring the electrical grid like one of our customers are, or you create multiple thousands of agents and put them on one server, and they're bringing in all this data. And I'll get into the examples on how they actually set up the infrastructures. And then you build these streaming applications with Java. And these streaming applications are really just your business logic. That's what it is. What is it you wanted to know? Who did you want to know it from? Where, when, what data sources, and how it should be displayed. And that's it. And organizations are up in a day or so with building these agents, because we use commonly used framework, Java, to build them. So if you think about it, what I just said is just out loud here. Business units get together. I want to know X, Y, and Z. I write down my business logic. I code it in an application using Java. I apply that to the stream, and I get my answer. That's it. It is that simple. And then, as the output, you decide what to do. The answer is potentially nothing. These dashboards are happening. The data's gone. It is gone. You don't need it. The bus has moved on. Or you send it to storage, cold storage, to decide later, decipher later, whatever you need to do. So what did we do here, and how did we do it? The satellite demo, we used Node.js. We created a generic Kafka producer which fetches the satellite data. And that data is actually coming from spacetrack.org. So the reason I started with that data, that's actually static data, just to show you the concept of what you would need, why you would need certain data to be real time. And what you really do there is really just create these swim agents, these applications for each satellite, store the real time, and these agents now, they store the real-time location, where they are, continuously updated, so what the debris is, rocket junk, location. Now, the cool thing about these applications when you build them is the applications can aggregate into one. And so you can have the applications share data with another application and then aggregate it to a dashboard. And then you have your actual results. And then you build in a UI layer, what we did right here, using Mapbox, mapping tool, and you're up and running. With the transit demo, what we did is we created, or sorry, we didn't do that. Cubic created agents for each bus. Because each bus now has some type of transmitter on it that is sending data about the environment, speed, velocity, etc. And send all that data to the various agencies. And the reason I say various is when you saw on the map, there was Reno, there's Seattle, there's Portland, there's all these agencies that are collecting this data now. And then they decide how they want to parse it. What I gave you was a centralized view of Cubic. San Francisco does not see all the other agencies that are going on. And then connect that UI. And all this, if I was to show you, is available to get you up and running with your Java developers by the end of the day. Most of our customers, if they have a Java development background, have a team, build these connector agents up and running really, really fast, just based on the space demo. That is it. That's how simple they are. So with that being said, I know I'm running out of time. We talked about Verizon. They're bringing in about 140 million devices, 10 gigs of streaming data. So we're talking intense volumes, right? When you're talking streaming data, you have to have that volume. And of course, last but not least, how do you get started? Figure out what you need to know. That is the most important thing, right? Look at your current dashboards, right? Where, why, what about the data? Where does it need to come from? Why do you actually need it? Why is it coming in? What is it you're trying to find out? And then go ahead and build the streaming application with our open source Swim OS. It's available free, it gets you up and running, and you can build these dashboards and get that streaming data analysis by end of day or end of day tomorrow. With that, I am going to stop my presentation here because I know we're getting close on time. But thank you so much for your time today. I appreciate it. If you have any questions, I can take a couple right now, or I'll just stand over outside in the hallway. Thank you.
Yeah. Thank you, Manish. That was really good, and that was a fantastic strategy starting out with that game. I think it did wake everyone up from lunch. So does anyone have any questions for Manish? Oh, there you go. Right over there, Manish. Oh,
sorry.
sorry.
Which way am I looking?
Oh, I don't know. Go, sorry. Perhaps I'm a lefty, so maybe. Go ahead.
Wonderful presentation. I'm from BI background, and so we use like a kind of BI to like a data warehouse, like do some kind of like dashboard, use Power BI or Tableau.
Mm-hmm.
So it looks from yours, kind of we have kind of application we want to do like streaming. So we look at the different kind of infrastructure like Kafka. So yours it looks like you use that, but also you're using like Java. You said to create
To develop the app, yeah.
Web agent.
Yeah.
So how do you create a dashboard? Just curious. Like the dashboard is created like a web page, like Okay.
Yeah.
So not directly using some kind of a dashboard application.
No, yeah, like
build yourself.
Yeah, so you're thinking, can I apply Tableau's dashboards to the data? Is it what maybe you're thinking?
Yeah.
You know what? I've never actually tried that. I should look into that. But yeah, no, you build your common web UI up front. And so what we're doing as we move forward this month and next, what we're doing is we're releasing, so all those use cases I just very briefly talked about here. Let me bring it. Well, we're going to create templates for these so you actually have minimal amount of coding and the dashboards and everything will be ready for you to go. So if you go to swim.inc.ai and continuously keep looking or ping me, I'll let you know. So we're trying to get a lot of the work done for you to really, I don't want to, once again, buzzwords, move towards more a low-code environment, whereas you're not doing as much as development. You're using more of our runbooks to get up and running with the common themes. Who was next? Yeah, well, the concept really is you got streaming data, streaming applications, which really do something, right? They're the continuous business logic. But the output is what? Streaming answers. The streaming answers are moving at the velocity of your input. So they're constantly changing, right? Like with the Palo Alto demo, it's changing, right? Because the traffic lights are changing. So the answers to Palo Alto's questions of how many pedestrians are standing clicking things is changing literally every second, or whenever the light changes, every 30 seconds, or the traffic flow. So streaming answers are really the output of the velocity of your data.
Thank you.
That's a very demo. Just to put it into perspective, how Swim will be different on pros for Swim versus Spark Stream or Kafka Stream?
Well, so we're an ingestion engine. We're not a streaming, so we ingest the Kafka stream, right? So that's really our data source. We're not a data source generator, provider, et cetera. So that's really it. We're looking at the stream coming in and applying the logic to it. So you always will own the stream, whatever you decide to do, however you generate it, and we'll work with whatever the data stream's working on.
Can I accomplish the same thing that Swim is doing by simply beefing up my ETL and API servers? Can I just make them stronger so that they process the data faster? So for instance, today I get data ingestion of data from some data source somewhere. Couldn't I just simply have the servers with more memory and more processors to grab that data quicker and deliver to where it needs to go faster?
I think where you always, like I said, it always depends on the current situation of the answer you need and how old it can be. And old is defined by you, right? So at any point where you have to have a write to a data, now the next question is if I make even faster disks, right? So, you know, is 1 minute okay for you in your business situation? And if that's okay, then yes, then that's the right answer, right? But like I said, it's the use case you're trying to support, and the milliseconds or seconds you lose depends on the business SLA you decided to provide your team, your IT department. So can you get as close to? I'm going to say no, because as soon as you hit storage, you've disrupted the stream. You're processing faster, but you disrupted the stream, which defeats the purpose of streaming technology, right? So our thing is never disrupt the stream, capture it in it. So we're doing in-processing. We don't put anything to storage. We're doing in-memory processing, right? You're putting it to storage and processing. So once again, the answer is always, what is your business use case? How old can your data be? And is that okay? And then sometimes the answer is completely fine. It's 5 minutes old, 1 hour old, 30 days old. And that is okay, just the use case. Cool.
So on that last comment, so if you wanted to do, because there's probably some other part of the business who wants to do some analysis on those screens.
Yes.
So is that a different story? Is that like a different pathway for that? Because it has to be stored someplace in order to do like.
And we can pull out of it.
Okay.
Yeah.
But this process is not storing it there. Something else is putting it in storage.
Yeah.
For some other purpose.
Sorry, let me correct that. So yes, you always have two types of business units. You have analysis that is looking at long-term things, and you're looking at certain teams that are looking at it now. So if you have a data stream that's coming in right now, those streaming answers can be put to an output, put into a cold storage, and they can be analyzed. Part of the benefit of that is you've gotten rid of data you may not have needed. The other option is that you put certain amounts of data into a store, and then you can actually use the app to actually combine static data, at-rest data, with streaming data to actually build a dashboard. So you've got different options that you can do depending on the industry you're in and the requirements of each division. But if you have specific questions, you can definitely send me an email on that. Cool. Well, thank you so much for your time. Enjoy this great day in Boston today.